Hey everyone, and welcome back to part 4 of our API and integration on Azure series. If you've been following along, you know we've already covered the basics of building and deploying individual APIs, but today we are seriously leveling up. We're officially putting on our senior multi-cloud architect hats to build a highly scalable, fully governable ecosystem. This explainer is all about the big picture, how we take all those isolated components and weave them together into a robust enterprise fabric that can actually handle the massive demands of a modern digital business.
Okay, so let's just jump right in with the million-dollar question, the one that literally keeps enterprise architects awake at night. How do you securely route millions of requests across a mobile app, a web dashboard, and legacy on-premises systems without creating a massive, crippling bottleneck? Because let's face it, when you have a highly distributed ecosystem, a simple point-to-point architecture just completely falls apart. You end up with a mess of spaghetti code, huge security vulnerabilities, and systems that just crash under heavy load. We absolutely need a smarter way to manage this traffic.
To figure this out, we're going to map out a comprehensive architectural blueprint today. We'll quickly hit the multi-channel challenge, layer in some gateways and BFFs, talk about integration hubs and logic apps, conquer hybrid and multi-region setups, and wrap it all up with some core design principles for scale.
Let's start by looking at a real-world enterprise scenario that demands a seriously advanced setup. Here is Section 1, the multi-channel challenge.
Picture this. You got an enterprise application that is literally the anchor for your entire business. It has to seamlessly serve a consumer mobile app, a complex web dashboard, and a high-volume B2B partner portal, all at the exact same time. Now, in the old days, architects would try to build one massive generic API to serve all three of those channels. And the result? Well, the mobile app gets super sluggish because it's downloading data meant for the web dashboard. And the partner portal suddenly hits rate limits because the consumer app is having a viral moment on social media. The whole ecosystem just collapses under its own weight because that generic approach simply cannot handle diverse specialized demands.
So how do we fix it? By introducing some highly intelligent layers. That brings us to Section 2, layering gateways and BFFs. To solve that generic API problem, we enter the backend for front-end, or BFF pattern. And it's exactly what it sounds like, a dedicated backend service created strictly to serve the specific needs of a single front-end interface. Instead of a clunky, one-size-fits-all backend, the BFF acts as a specialized concierge for each specific device type. It only grabs the exact data that specific client needs, formats it perfectly, and sends it on its way.
You can really see the stark difference when you compare a mobile BFF to a web BFF. A mobile BFF is like a minimalist. It aggregates multiple downstream microservice calls into one single request to save your phone's battery life, and it heavily compresses that data because it expects low cellular bandwidth. On the flip side, the web BFF handles much larger payloads for those rich browser dashboards and deals with entirely different cookie-based authentication flows. By splitting these responsibilities up, neither client has to compromise on performance or security. It's a win-win.
So the crucial takeaway here is the strict sequence of how a single user request flows through this architecture. Step 1, the request hits Azure API Management, which is our overarching gateway. Step 2, APM securely routes that request to the appropriate backend for front-end layer. And finally, Step 3, that BFF makes the highly optimized calls down to your internal microservices. By enforcing this layered sequence, your internal microservices remain completely abstracted and protected from the chaotic demands of the outside world.
Let's keep moving and see how we orchestrate the actual workflows behind the scenes. Welcome to Section 3, Integration Hubs and Logic Apps.
Listen, it is absolutely vital to separate how data enters your system from what your system actually does with it once it's inside. Think of Azure API Management as your strict customs and border control agent. Its entire job is validating passports, checking luggage, and letting data into the country securely. Conversely, Azure Logic Apps acts as the internal integration hub coordinating the actual business logic. You really don't want your border patrol trying to build the cars on the factory floor, right? Keep your gateway focused on secure data transfer and let your integration hub handle the complex workflow orchestration.
By using Logic Apps as the glue, your APIs are suddenly freed up to simply transfer data while the hub handles all the heavy lifting. Logic Apps seamlessly connects disparate enterprise SaaS platforms, like, say, routing a new user from Salesforce straight into an SAP database. It visually orchestrates multi-step business processes, complete with conditional logic, retries, and error handling built right in.
But most importantly, it enables event-driven triggers across the entire ecosystem. So when a new order comes in, 5 different back-end systems are instantly and reliably notified, and you didn't have to write thousands of lines of custom polling code to do it. It's brilliant.
But hey, the real world is messy, and enterprise architecture is rarely 100% cloud native. That brings us to Section 4, conquering hybrid and multi-region deployments.
Azure actually does an amazing job of bridging the gap between modern cloud services and those deeply entrenched on-premises legacy systems. On the cloud side, we've got our sleek cloud-native routing using Azure APM with modern JWT token authentication. But on the legacy side, we have the reality for most big enterprises, older mainframes hugging the ground on-prem. Azure solves this beautifully by using virtual network or VNet integration. Your APM instance can literally project a secure tunnel right down into your corporate data center, seamlessly routing requests to legacy protocols as if those ancient servers were sitting right next to your modern cloud microservices. And when your user base goes global, you absolutely must implement multi-region considerations to ensure low latency and high availability anywhere in the world. A true enterprise architecture uses active-active APM deployments. That means your gateways are running hot in, say, both North America and Europe simultaneously. Use geographic traffic routing so a user in London always hits that European gateway. And crucially, you implement cross-region state replication. This ensures that if an entire geographic region suddenly goes dark, your ecosystem just fails over gracefully without losing a single transaction. No panic necessary.
All right, we've built out this massive, globally distributed, hybrid beast of an architecture. Now we need some ironclad rules to keep it from descending into total chaos. Our final section, Design Principles for Scale. Here are your 4 definitive design principles for building a scalable, governable API ecosystem on Azure. Number 1, always decouple your channels using the BFF pattern so your clients aren't fighting over resources. Number 2, enforce strict API contracts, like open API specifications, so front-end and back-end teams can develop independently without breaking each other's work. Number 3, automate your APIM governance policies, deploying them as code so security is never just an afterthought. And number 4, implement end-to-end observability using tools like Azure Monitor and Application Insights. Why? Because you absolutely cannot govern an ecosystem that you cannot see.
The huge takeaway here is that true enterprise governance happens right at the edge, at the gateway, neutralizing threats and enforcing rules centrally. Effective governance means applying rate limits, strict security validation, and usage policies directly at the Azure API management layer. By doing this, malicious traffic, malformed requests, or accidental massive traffic spikes are killed dead in their tracks. They're stopped cold before a single internal microservice or legacy on-prem server is ever touched. It preserves your compute power, and honestly, it preserves your budget.
As we wrap up this explainer series, and you get ready to design your own advanced Azure integrations, I want to leave you with one final thought. Building for scale, that's really only half the battle. As your ecosystem grows to incorporate AI agents, real-time streaming data, and hundreds of new partners, the true test of your multi-cloud architecture won't just be how much raw traffic it can handle. It's going to be about how easily you can govern, adapt, and secure it all. Your architecture can scale globally today, for sure. But are your governance policies actually ready for the APIs of tomorrow? Something to think about as you build. Thanks so much for hanging out with me for this complete explainer series, and I will catch you in the next one.